introduction about the background. A couple of months ago, I was contacted by Jens Ole, Björn Moos, for people who know IRC well. And he was talking to me about the fact that there's a lot of stuff going on in the physics coding side of Blender, but we are not communicating well enough. So his idea was, would it be possible to have some kind of a meeting with the developers in real life to set some standards for API and have an agreement on how to do this whole development. At that time, the Blender Institute plans were getting more solid. So my proposal was, so let's get people who are going to the conference anyway, let them come to Amsterdam 2 days in advance. And then we have a meeting room for 2 days to talk about how physics is going to be organized. That plan was realized, so Jens came, and we invited the particle developer, this is Janne Karu, also known as Yaka, the Yaka particle, everybody knows that particle system. We have our cloth developer, Daniel Genscher. Daniel couldn't be here today, that's right. He has other things in the city. We have Campbell in the team. We have Brecht over there, and we have one day Neil Steely of the Fluids code coming over. And together we discussed a whole lot of topics, and we published it on the internet. Did you find it in the wiki?
It's here, I can put it up there, or? Yeah? Okay.
The physics print is on the website too, there you can hear the results. But Campbell is going to mention some of the highlights of what we've been doing. And if you have questions, just interrupt us, and then we will have some discussion. Campbell, go ahead.
Okay, well, I was organising the ideas and putting them down in the minutes, so I had to get an understanding of what was a physics solver and how the physics system should work. And so I'm not actually writing cloth or particle simulations or anything like that, so I'm just to warn you, the hard questions can go to these guys. Alright, so the first topic I'd like just to cover is what is a physics solver, because I'll be using the term solver quite a bit. A physics solver, well, just from the user level, you could think of as fluid simulation, particle simulation, cloth, soft bodies, rigid body physics. And a solver takes this, takes the Blender scene or the objects you have at that point in time, and runs over time and continuously reevaluates and recalculates the physics for that scenario. So, and the next thing is why do we need multiple solvers? Because simplistically, you could say that we should just have one big solver that does everything, and it does all those things I just mentioned all in one go. But we can't do that because physics just by itself, say rigid body physics or fluid physics, is extremely complicated, as people who are aware of development would see that the fluid simulation is better than some other commercial applications, and was a big project in itself. So we can't just have this one big physics system. We need to have different solvers to solve all these physics problems.
You can list it easily. If you look at all the features in Blender, the particle system that is a physics system too. It's just little particles floating around in space and interacting in some way. Fur and hair is actually also a physics system. It has to have some kind of interaction with the environment. You can simulate it. And we have soft body, also another physics system. Cloth and soft body, although they do overlap, it's easier for the development and for Blender to keep it separately. Soft body is for the fun thing, for the body stuff, for things you want to have exploding, things for dinosaurs with muscles and skin bulging. And cloth is something that has to be totally stable, restricted to be cloth simulation. The cloth is only one good cloth, which is cloth that looks like cloth. There's only one way you want to make cloth, but plenty different ways of elastic stuff that flies around. Then we have rigid body dynamics, which is not yet in Blender, but we have solid, bullet as a library in the physics in the game engine. That one still has to become a tool. Then we have collision detection, which is part of bullet. Actually, it's not physics. Collision is also a simulation system. And then we have fluids, and I think that's the physics system at the moment in Blender. So all these systems share one thing, which is it's a simulation system. It works with time and time steps to find solutions based on forces and physics rules.
Okay. So what we decided pretty early on was that we needed a unified solver API, so the fluid simulation didn't need to go and find out where it was hitting things and cache or store the previous frame and do these complex algorithms. And the particles was doing its own way, and Daniel, who wrote the cloth modified it his own way. It's really, really horrible that they have to go and do all this work just because they want to know what intersects with what. Yep, collision detection. So, and there's other problems. So we needed a common API that doesn't do any of the physics, but has handlers so the objects can know when they need to be collidable, and solvers can call these generic functions. So it's less work to add and improve solvers. This is also something that the animation system would control. So when the playhead is moved, or when you go back a frame, it can the animation system should be able to have pre-calculated certain frames, so you don't have to recalculate all the frames up until the current frame. I'm sorry, and just when you go back a frame with the current soft bodies, it messes up, and that's something some of you will have seen, and that's quite a big problem. So the animation system should work with that. Also, the animation system needs to keep track of what needs to be in the collidable. So, for instance, complex objects will need to have their own physics world or collision world. So there will be, say, an octree of faces in this special this area that isn't seen, but it is used for collision detection. And so the fluids and all the different solvers will be able to access this collision detection information in a generic way. Okay. So Daniel actually did quite a bit of work, probably the most work in this area. He with the cloth modifier, which isn't in Blender right now, but he did a lot of work with face collisions and vert face, edge face, things like that. And that's at quite a advanced level. We can probably use that to put in, to rewrite parts of it and put that into Blender to make this collision system. And this is something that other areas of Blender can use too. For instance, it might be nice to have Python being able to know if things collide, or even as the transform tools, you could drag a box on top of a box and they'd hit together, things like that. So it opens up a whole area for interesting tools in Blender that make use of physics. But that's more in the future. We didn't really discuss that so much. The next thing, which isn't user visible, but at the moment you have to bake. You'll have to bake a mesh or bake fluid, and this whole idea of baking, it's quite clunky. You shouldn't have to be aware of whether the information is baked into the mesh and that there's files somewhere. It should just, you should play once and it calculates that, and then you can pull the playhead backwards and forwards and see the simulation, and it will recalculate areas where necessary. And we spent quite a long time working this area out, that we would have what's called a solver cache. And so it's transparent to the user and the animation system. And it should be fast with no manual baking and no manual interaction.
Just as an example, people know if you use particles now in Blender, every time step it has to go over the whole system again. It pre-calculates on specific key position the particles. If you have a more complicated animation setup with lots of characters moving, and you want to have one character waving with a torch, to be able to calculate the flames of this torch, for every change you make in the animation system, it has to move back the whole character to the frame 1, and then animate everything completely, including the deformations, etc., to be able to make this one little frame working. The new particle approach is to, by default, not bake everything, but work in forward steps. And the difference between baking and a cache, it means that you just still store everything as if it's baked, but it's going to be more dynamic. It's just going to be hidden for the users. You don't have to press bake buttons, but if you play back the animation once, you will have a cache of everything anyway, so you can rewind and forward animations.
Alright, so this baked information will be stored on disk, because if you've got a really high poly mesh and you've got cloth information in there, it's going to store a whole lot of vertex positions per frame, which is huge, and we can't do that in memory for any length of time. So we agreed that we needed to store this on disk, and that can work kind of like textures, where you have / textures, and it will automatically put that information on the disk. So for particles also, and for fluids as well, but it will use a generic system for that.
Ideally, you should be able to work on a machine, and you quit lambda, and you load lambda again, you load that specific scene back, and everything should be in that state, including particles and smoke and soft body and fluids and whatever simulation you had been running at that time, and be in the cache, and be on a disk cache, can be transparent, disk cache or memory cache. We should be able to handle that in a way that you don't feel like you are bothered with baking all the time.
Okay. And the other thing is with render farms, this came up that we might want to have it so we send a frame to the render farm and it can go through and generate the whole cache before it starts rendering as well, which would be nice. The next topic is solver interaction. It would be really, really nice if all the solvers of the cloth and the rigid body physics could interact with each other. It's a very complex problem though, and there's no perfect solution for this unless you have one big physics system that does everything. So we can't really get away from the one frame lag problem, which happens when you have, you'll notice in the soft body sometimes at the moment, you'll have something happens and it only realizes the collision a frame too late. And you're not going to notice that too much if you're watching a fast, 24 frames a second or whatever, but it's not very nice, it's not very good. So
we designed for that also a system that you want to combine multiple physics systems, that every previous physics system is going to be treated as if it's an animation system. So by definition, all physics systems will be able to handle animation systems correctly. So if you have a character moving around in the environment with all the polygons and the hands, whatever, particles can always collide with the skin. Or the fur will be correctly put on top of the frame, on top of the skin. But once you've done the fur, the next step, which could be like rigid body blocks falling down, they're not going to be deforming the fur, because the fur then is treated as a static animated system. But the blocks will still nicely fall against the animated character. Even when it was a soft body system first, if you do that first and then you add a rigid body system, the rigid body system will nicely collide with the soft body system. You can still follow me. You have to make your order for that. But you can imagine the fact that the animated systems always have priority. You have to fully evaluate an animation system to be able to do a simulation. And this fight between animation systems and simulation systems is a very famous problem in the computer graphics. All big 3D programs are fighting with that. So how do you integrate a nicely walking character with a physics interaction? This kind of stuff is complicated. How do you do that? Because I'm forced to go back, but I'm animated. So in normal situations, the character is walking and this thing moves away. So that's the problem of having animated systems and physics. Yeah, even the water is physics, you see that? The water simulation reactor. So in real life everything is much more easier. But in the Blender world we have to separate things in animated. So once I am animated, I won't have any response back anymore. It's impossible. You have to decide when you design a world. So when is something going to be static and when is something still dynamic? That's all in the modifier stack, so you can still layer things. So for example, you can have 5 levels of soft body on top of each other if you want to. And the second level is going to be dynamic using the animation of the first level. Can you imagine it? I think how useful that is going to be. Yeah? Yeah, he's smiling, he knows how good it's good, right? It's a good plan. Okay. Nobody believes me, but that's how, well, you guys code it first and then we will see, right?
Then we'll shoot it afterwards.
Okay, editable bakes is the next thing. And that's your name, sorry, Jaffa has already has already done editable bakes in his own branch, but we're going to change how that works because we want to make it so all physics systems are editable, because there's always situations where the cloth won't look quite right, and even tweaking the settings, you just want to go in there and pull the vertices around. So this will be done as a modifier. So you'll actually be able to apply a modifier on top of the stack that allows you to change vertex locations. And it could be, you could think of it like an extended mesh key system, though we're not sure how much keyframing and things we're going to add. You'll at least be able to go in and change a baked mesh and have that changed per frame. For the fluids, it will work differently. We might not have that in so early, but we want to have it. We still do want to have it, and Nils, who wrote fluid, says it's very important because sometimes there'll be a droplet of water somewhere, you'll want to get rid of it. So we'll have to have a editable bakes for fluid system that works a bit more like stop motion, where you just have access to each mesh sequentially.
That baking also allows us, in a later stage, to turn a baked animation system back into keyframes, like shape keys. So you have the whole system back into a sort of much more simple shape key system with interpolation between it. That's very advanced, we don't know how to solve it, but the baking thing, or the editing bakes, is actually can be turned into a shape key system.
Yeah, we talked about some things like that, and they'll be possible, but it's sort of how far to go and how much work it's required. Brett has some good ideas with that. Alright, what's in order? Units is the next thing. It's not such a big area, but Jens had a lot of feedback about units and saying, well, you've got to have a pendulum swinging from this distance, and that 1 meter requires this much time, and so there's a real need for physics systems to know how big a blender unit is, about time, and scale. Time, distance, gravity. So Blender, that's not too hard. For the distance thing, that's not too hard. We can have each scene having a blender unit is a centimetre or a metre or a kilometre, an inch, that kind of thing. And interface support will be really nice, but that can be added later. So a lot of people in the CAD world request that we have inches support, imperial support in Blender. But to start with, we just need real-world translation. The other thing is we need presets, because all these crazy fluid simulators, and that has presets, but all these simulators or solvers need to have human understandable presets, and so we're going to make sure that we have something in that way for each of the solvers. We could do that through Python as well, where Python can define the presets, people can add their own. And that each solver can independently scale their time, distance and gravity. Because one example that came to mind before was that you might want to have is it called stop time thing? Imagine the thing in the Matrix where they do that slowdown. You could have cloth happening at one speed on one character and another speed on another character, and you'd want to have independent scale in that case, or time scaling at least. And that could also be IPO controlled. Now, all this stuff will take a lot of time to code, and we're not sure when it can be done by, but the priority for Brecht and the pitch team, for myself and the pitch team, is to have particles done as soon as possible, but done in a way that doesn't need to be hacked up later, because Jana's branch is very good. A lot of people use it already and really like it. But we need it to be done in a way that won't be messy. So we'll need to implement these features that we've got in a way that we can keep using, and in a way that we can then add other systems in to implement parts of the API. And Ton suggested that SIGGRAPH, the next SIGGRAPH, is the target for all this being done, but I'm not sure. That's wishful thinking.
We have to cut a target, but we also have to make movement. The particle system is already very far, but a couple of crucial things have to be done. For example, changing subsurface levels is not. It's a very complex issue, because the particle system already allows you to point other specific location on a mesh and have one hair growing. So you can click, and have lots of hairs on different places. But what happens when you subsurface level one deeper, or when you remove the subsurface levels, the hairs have no idea anymore where they should be. It's a complicated issue. We don't want to bother artists with that, but it's a complicated issue to code, so that we don't know yet how far we are going to get with that. Might be solvable.
And it might have to be solvable for micropolities separately we've talked about that.
For beats, I think with the current state of the particle code and the hair code, we might get very far. I think it's totally feasible. But of course you guys have to admit it's going to be feasible. No complaints? No?
So far, a few.
Okay. I'm done.
Yeah, I'm done.
They're all done. Okay. What to do is, of course, a lot of coding work. The result is, for me, that I now know who Jana is, I know who Jens is, I know who Daniel is, and what kind of mindsets they have, or why they react in a way when you talk to them, how much time they would like to spend, what they can do, what they cannot do. It's totally good to have this kind of interaction going on with the physics team. So I'm pretty confident that physics code and blend is going to be there for a long while and going to improve a lot over the next year. So I would like to thank you guys for doing this sprint. This was great.
I just want to ask what about the game engine? Although it's nothing to do with movie making, but it seems that it's always left on the side.
It's still going to be left on the side as far as I know.
The game engine was not really a topic. But the game engine already has a physics system. Without physics system, we don't have a game engine. Yeah, bullet, but also.
It's not really, I think you get only spheres, not even convex polygons if you want to play with. You cannot set hinges, joints or anything the way you want. If you want to implement a special acts of freedom that evolve over the time, then you have to program that or whatever. I mean, it's not implemented in the Blender GUI, so is it going to be improved by the time? Or?
Not for the game engine. It's just not really a feature we need, and other people maintain that, and there's not many of them, so it's.
Maybe we should point out that at this point the physics system we've been talking about was soft poly, was particles, and was cloth and fluid to some extent, and all those systems are particle mass systems, and they distinguish from the rigid body systems, which the game engine supports. Those particles have no volume, and so have no inertial of rotation and things like that. So we're dealing with a complete different system for integration with methods. So we didn't deal with problems the game engine has at all. Okay?
I'm going to ask the $1 million question. When?
You have a whole long list.
Yes, of course. Oh.
What I said for us as a team, the hair stuff is most important at the moment. But the Peach team is going to storyboard the whole movie the next 2 weeks, I think. And probably they will add some crazy ideas, which might need some, I don't know, where's the crazy idea person? He's not here at the moment. He will present tomorrow. But we might have some crazy ideas in the movie which will need more physics control. Personally, I would like to add the wizard body system as soon as possible. Because that's fun. It's really a fun toy to play with. I want to have it as interactive as possible. I also discussed during the physics sprint that we should make the lambda interface running the simulation always continuously, even when you don't have frames advancing. That can be a separate option or maybe by default, but the advantage is that things keep going on. So you can, for example, you find a object to be soft body, then you grab it with your mouse, you shake it around really wild, you see, this is not working, it's too flexible, so you make it a little bit stiffer, you shake it, now it's nice. And then you parent it on top of somebody's head, and then you know it will be fine. Because you can shake it, you don't have to wait for his head to animate to see if it's going to work, you can just shake it with your mouse. But to be able to do that, you need the simulation to be continuous. The same is, a couple of years ago, Weber showed how Lightwave has particles integrated. It also runs continuously, the simulation. So you have particles going on. You add a force field, and then suddenly things start blowing away. You remove the force field, and things are not blowing away anymore. But that kind of playing, working in the 3D window, helps a lot speeding things up. So with the body, you can do the same. Not only like you can grab a cube, throw it away, and it should clack, roll around. Maybe you want to have it as a grabbing tool to stack things, so to say, a drop. And you don't have to align, but you can just have a cube dropping on the table. And then it's on the table. Yeah. That kind of things, wizard body editing and collision detection will help them. I like to work on that, when I have time. But there are more people, maybe. I don't have time. Never. And I don't have to do better conferences. Next week. Huh? So when we're going to do that, I don't know. We need more development support too. That's definitely a fact. Questions? There's all kinds of artists there sitting. Complaints? You also just want to know when, then you can try it, right?
So when?
I bet people who think, I like to code this, and I can't do it within 2 weeks. Yeah.
Hi, I just want to know, as a beginner, I don't know much about Blender. I just want to know how many things in Blender is threaded, multi-threaded.
Oh, not much. The rendering engine is, but we did discuss using OpenMP, which to beginners or for people who aren't aware, this is a multi-threading system that can be easily added into source code. It doesn't do some of the more finer optimizations that you might want, but Daniel was able to speed up his cloth modify 25% with I think he said 2 lines of code. It's a sort of thing you put in there and it knows to split it up into 2 threads. Yeah, so what we'd like to do, what Todd would like to do, we'd all like to do this actually, is get the animation system threaded first, which means that modifiers can be calculated in parallel. So you can have all the objects in the scene and say, assume all of them have subsurf, it goes to the next frame and it goes through and can thread the calculation of all those. And then after that we can see what the benefit is on having, say, subsurf itself threaded.
Developers love to do tasks on one cube, but that's in control. You can easily see how much one cube is. So, for example, the cloth developer, he said, really, honestly surprised, but why would anyone use more than one cloth in a file? No? One cloth is more than enough. Well, the artist, if cloth is working, suppose it works really nice and interactive, they're going to put cloth on everything. So yeah, it's not useful to have a lot of work in optimizing one cloth simulation to be multi-threaded. It might be much better to multi-thread the whole animation system by default. Now whether it's cloth or particles, what kind of modifiers, it doesn't matter, it's being multi-threaded. Because people are going to use dozens of objects, hundreds of objects.
But the argument to that is that you have an armature and a very high polygon mesh with, say, modifiers and subsurf applied. If you just drag the arm, it's really slow. It doesn't matter how many other objects you've got in the scene because it will still be stopping on that one object. So there's arguments for both.
Probably both, having both is always better, but most likely people are going to use a lot of character animating together in one shot.
And that's probably when it will be a problem as well, because one character is usually fast enough on the computer, whereas 100 characters will gain more, but we'll have to see.
I mean, one of the issues also was that that's why Fluid was put separate. And Fluid is not interactive, which is really bad, I'm saying, because it's how it is. It is extremely complicated. So Fluid only works well if we use it standard in a sort of a baking mode where it saves everything to files, and you wait the whole night, and the next morning you can see how Fluid looks like. But cloth and rigid body, soft body, all these things, they have to do with your animation, and we have to aim making that interactive and immediate and responsive as possible. Otherwise you will not use it, or only use it as a special effect in some cases.
And what about mixing fluid systems? Is there any project to solve this? I mean, for example, when you have a first fluid system consisting in oil, dropping into a fluid system consisting of water, for example. When you have two fluid systems, oil dropping into water.
Yeah.
Actually, it is not possible to have different viscosities.
I think Nils mentioned something. Did he mention that?
Not really.
What are you talking about? Oh, okay.
Not really.
Well, that's, yeah, I mean, the whole thing with this is, what we're planning is that it's not really specific to each solver. Each solver has to manage time and physical problems in its own way, and this is just a way to tie them together. So for that, you'd have to ask the guy who writes the fluid simulator. But yeah, I don't know.
Did you try?
I'm pretty sure you can't do it.
But he's not here, so. Come with your questions.
And what category must the volition script? Do you know what I mean?
Yeah, I know the script. It would be added in a similar way to the cloth modifier, but it's a script at the moment, and if you're happy using it as a script, it'll keep working. It's just that would ideally be added in the same way that the cloth modifier will be added as a part of this, or using this API. Yeah. Yeah, the script is a separate program that runs in Python, and it's cool, but it doesn't make use of any of the things we're talking about. It just must do it all its own collision detection, and that's a big disadvantage when you're writing such a tool, because you can't spend all this time making the solution really good or the physics really nice. You have to spend time messing around with faces and collision detection. It's a hassle.
Yeah, I have one question. I wonder if in the unified baking part of this whole project, are you considering exporting the meshes, the editable meshes, to other applications, like to be able to import a fluid simulation into, I don't know, 3D Max?
Well, we've already got MDD support in Blender, read and write, and Matt Ebb developed Point Cache, which works in 3 Studio Max. I think that's a separate issue. Fluids, there's no simple way. They're just a whole lot of meshes. They're just meshes. So you export a heap of meshes. Unless there's a specific format that's best for this or better than what's around, we can support that. But there isn't anything planned. No.
Because, for instance, an MDD format, I think it doesn't support currently meshes that change the number of vertices. It
won't support that. No. It's just the changing meshes or deforming meshes.
More questions? Yes?
So you're actually looking to have proper rigid body simulations as you do soft body, which currently is limited. There is no rigid body simulation as you use the engine. You will have a proper option to
Yeah, that's the idea. We haven't got anyone. Well, there's Bullet, and we're not sure about that, but there isn't anyone who we know that is wanting to add that in. Whereas the others, we've got a developer for each simulation type. We're thinking maybe a developer could look at adding Bullet in this system, and that could work really well, because Bullet is a good rigid body simulator. Just doesn't work for these systems so well.
Well, the problem with the rigid body simulation would be all those particle simulation like soft body and particles and cloth are below object level, so they just simulate the behavior of the world inside the object, while a rigid body system would affect the object itself, so the markets of the object itself. So it would be a complete different system which widely would interfere with the animation system directly, because the object starts moving will be driven by the dynamics of the object. So somehow the animation system, which usually drives objects via eyeballs or via images, must be deal with that information. So we have to talk about that.
We're not there yet. Okay. Campbell, thank you. Was it close?
Yes.
A few minutes break, and then we go to the next presentation. Blender is my workhorse. Blender in the studio.